take one of the example. A boy cycling says that the wheels of the cycle are making 140 revolutions per minute, and then if the diameter of the wheel is 60 centimeters, calculate the speed per hour with which the boy is cycling. So let's take the boy is cycling. The wheels of the cycle are making 140 revolutions per minute. So total it making 140 revolutions. So diameter of the wheel which he is cycling is 60 centimeters. It's the diameter of the wheel, that is 60 centimeters, and we need to calculate the speed per hour. So let's take the circumference. We have learned circumference of the circle is nothing but 2 pi r. So the reason of taking 2 pi r here, the wheel is making rotation, so it's nothing but perimeter of the wheel. It's complete the 140 revolutions, so that we need to take the circumference of the circle. So here, let's find out for one revolution what is the distance covered by the wheel. So C is equals to circumference is equals to 2 pi r 2 into 22 by 7. We'll take the pi as constant. We know that is r into r. We need to find out the r from this. R is equals to half of the diameter, half into 60, that is 30 centimeters. So let's take 30 centimeters here. So we need to find out the circumference of the circle which is making one of the revolution. Let's multiply the numerators. 44 into 30 by 7. So let's multiply 1320 divided by 7 centimeters. So if it is making one round, the revolution of the wheel for one revolution it is 1320 by 7 centimeters. But it's making 140 revolutions. Let's find out what is the distance covered by it for 140 revolutions. For one of the round, it is 1320 divided by 7 centimeters. For 140 revolutions, that is into 140. So let's do the cancellation. One time, and this 20 times cancel. So 1320 into 20. So let's multiply this. We're getting 26,400 centimeters. So let's see the problem here. It's given speed is per hour. So we need to find out the distance must be in kilometers. When the speed is per hour, we need to find out this distance into the kilometers. So here it is given in the centimeters. So let's change this 1 centimeters into meters first. So 26,400 divided by 100, then it changes into meters. So let's cancel this 2 zeros and 2 zeros. We'll be getting 264 meters. So this is only the meters. So we need to change this part into the kilometers. So 264 divided by 1000. So this meters will become the kilometers now, because 1 kilometer is equals to 1000 meters. So now the distance covered by the wheel in 140 revolutions, it is 264 by 1000 kilometers, but we need to find out in per hour. This is per 1 minute only because 140 revolutions per minute. It is given for only 1 minute. So let's find out this one into 1 hour. Then it becomes 264 divided by 1000 into 60. So this is per 1 minute. So 60 minutes it becomes into 60. So let's cancel this. 264 into 6 divided by 100. So after multiplication, 24. So 24. Then after multiplication, we'll be getting 15.84. That is kilometers per hour. So after multiplication, let's recall from here. That is 264 meters. And then after this one, we have changed into kilometers. Then it became 264 by 1000 kilometers. So we need to find out this one per hour because 140 revolutions per minute it is given. So this is per minute only. So let's find out per 1 hour. 1 hour is nothing but 60 minutes. So this is for 1 minute. Let's find out for 1 hour, that is into 60. So cancel this 0 0. Then we'll be getting 264 into 6 divided by 100. Then after the cancellation and divided with 100, then we'll be getting 15.84 kilometers per hour. So the speed is going by the bicycle is 15.84 kilometers per hour. Multiply by 2 on numerator and denominator, it becomes theta by 360 into 2 pi r. So this is 2 pi r is nothing but circumference of a circle. L is equals to theta by 360 degrees into circumference of circle. So let's take, instead of circumference of the circle, let's take area of semicircle. We know that it's making that 180 degrees angle. Then this is the area of semicircle. If you have taken area of the semicircle, A is equals to x by theta by 360 degrees into we are taking area of semicircle. So instead of circumference, let's take the area of semicircle. So then it becomes A is equals to theta by 360 degrees into half pi r square. So because of A is equals to, area of circle is equals to pi r square. So area of semicircle is equals to half of the pi r square. So in this we can observe there is 1 by 2 in common. Let's take 1 by 2 common in this. So 1 by 2 into theta by 180 degrees into 1 by 2 pi r square. So after that, let's observe in this, if we have taken x by 360 into 2 pi r, then it will be similar to x by 360 into 2 pi r. So that let's take one of the r to outside common as common. So A is equals to half into r. We are taking, so theta by 180 degrees into half into pi r, it becomes. So the reason of r here, the one of the r we have taken common. So then A is equals to half into r by theta by 180 into half into pi r. So 180 into 2, it becomes 360. So theta by 360 into pi r is equals to theta by 180 into pi r. So we multiplied by 2 in the numerator and denominator. Then we got theta by 360 into 2 pi r. So after that, 2 pi r is nothing but circumference of the circle. So theta by 360 into circumference of the circle. So length of an arc is equals to length of an arc of a sector is nothing but theta by 360 into circumference of the circle. So L is equals to theta by 180 into pi r, and after that they got, this is multiplied by numerator and denominator, they got it as L is equals to theta by 360 degrees into 2 pi r. This is we have derived just before, into 2 pi r. So let's take the half of the circle, that is semicircle. Area of secant is equals to theta by 180 degrees into half pi r square. Before that we have taken the length of an arc, which is less than 180 degrees. So for the semicircle we have taken, pi r, half of the perimeter, that is pi r plus pi r, half of the perimeter of circle, that's we have taken pi r, and an angle made by the arc, that is nothing but theta by 180 degrees. So instead of circumference, let's take area. So area is equal to theta by 180 degrees into half pi r square. You know that we have discussed that is area of circle is pi r square and half of the circle is nothing but half pi r square. So here we can observe that we can take 1 by 2 in common. We taken 1 by 2 common, so it becomes theta by 180 degrees into pi r square. So let's take one of the r into as common. One of the r we have taken into outside as common. So what will be left out here? That is theta by 180 degrees into pi r. So when we multiply this r into r, it will be balanced to r square. So let's see what is theta by 180 into pi r is nothing but L. So this is nothing but theta by 180 degrees into pi r is L. So A is equals to half into r into, this is L we have derived just before. So this is L. A is equals to half into LR. So the area of a circle is nothing but half of length of an arc into radius of the circle of an arc.